Right, this video is for those of you that have chosen a chi-square test of homogeneity for your research. One thing that you should have done already is watch the videos for sampling to make sure that you have chosen a good sample or that you have run a good experiment. For your chi-square test of homogeneity, for your report and for your presentation, the first thing that you're going to want to do is start off with an introduction, just kind of telling about why you chose this topic, why you were interested in it in the first place, and make sure to describe in detail what type of sample you've chosen to collect and how you made sure that that sample was random. Those two sampling videos give you some very detailed examples of the types of samples that you could choose. So with that part being done, what this document is supposed to be is a step-by-step process of how you can use Minitab software in order to report out on your findings. I encourage Minitab just because it does everything for you and it's very easily transferable to other documents, so you don't have to recreate everything that you do. If you do want to use the calculator, you certainly can. At the end of this video, I will show you the steps for running the test in the calculator. You can also do the graphs in the calculator, but the calculator does not transfer that information into your document for you. You would have to either create your own graphs or manually type what your calculator spits out for you, or you would still have to go into some type of Excel program and do those graphs. So I would encourage Minitab just because all of that is done for you. It's going to be a lot less work for you. So if you've chosen a chi-square test of homogeneity, then what you have done is you have collected data where you are looking at two completely different samples, both chosen randomly, and you're looking at more than two categories probably of the counts in those particular categories for those two different groups. And what you're trying to do is see, are the counts the same for the adults as they are for the faculty? Now, since your sample sizes may be different sample sizes, we're going to use our chi-square test to see that. So for example, for this practice problem, are adult perceptions of a certain college the same as the faculty? And we've got the categories poor, fair, good, and excellent. No answer for those different perceptions that we could have. And what we're trying to do is see, are the perception of adults the same as the perception of the faculty? Okay, so I've tried to set this up in the same way you should enter it into your Minitab document. So I'm this empty box here at the top. This is this gray area under C1, so I'm going to leave that blank, and I'm going to put my categories of responses across the top. So under C2 in this gray area, I will enter poor, C3 fair, C4 good, C5 excellent, and C6 no answer. And then down under C1 beside 1 and 2, I will list the different groups that I was looking at for this study. So I looked at what adult perceptions were, and I looked at what faculty perceptions were. And then I'm just going to enter the numbers that correspond to each one of these squares or rectangles. Okay, so I have my data entered. So what we need to do is look at this to see what do we see from this data. And the first thing I want to do is just summarize what I see with basic statistics and graphs and some visual things that I can use to help display this to my audience. So for the summarizing statistics part, you have 6 steps that you need to do in Minitab to pull up this graph. We're going to go up here to the top and click Graph. And we're going to choose the bar chart here at the bottom. Step number 2, in the pull-down menu, we're going to choose Values from a Table. And then we're going to choose the two-way cluster. That's down here at the bottom left. And then we're going to select OK. In step number 3, you're going to click in the white box for graph variables. And you're going to highlight all of the columns over here on the left. So from C2 to C6, we'll highlight all of those words. Underneath of that box, we're going to choose Select, and that's going to put this into the white box. And then for step 4, we're going to click in the white box that is called Row Labels. And then for row labels, we're going to highlight C1 only, and then click Select. Once you have filled in your graph variables and your row labels, you can click OK. Okay, and then in your table arrangement that this spits out, your columns are the outermost label. So here are the results for poor, here are the results for fair, and then within that, you've got the difference in that opinion between adult and faculty. Now, the good thing about Minitab is this: I don't have to recreate this graph. I don't have to go draw this myself. If you have a Word document, and I know a lot of you like to work with Google Docs, you may be able to copy and paste this into Google Docs. If you right-click in the gray area and try copy paste, that might work. But you'll notice that this sends your graph straight to Microsoft Word, or it can send it straight to Microsoft PowerPoint. So I'm just going to hit Send to Microsoft Word, and you'll see that it automatically transfers that graph for me into Microsoft Word. I can use this in my presentation. And I can click and drag this anywhere that I want it to go. It's probably not going to drop it exactly where I want it, so I'm just going to pull it down here to where I was doing these steps. Okay. Now, once you get through the steps, you'll notice that underneath I've given you a paragraph with 2 stars. And what this is going to do is just kind of lead you into things that you should be talking about in this graph. What do I need to include in my report about this graph? What could I talk to my audience about when I'm presenting my results? So discuss what you see in the comparison of your 2 variables. So as I look across here, looks like maybe the good category, we're pretty close. The excellent category, we're pretty close. Both were pretty low for no answer. But I do see some differences here in the poor and the fair. So it looks like we didn't really have a lot of faculty answering that their opinion was poor, but we did have quite a few adults. And we see a difference between the adult faculty here as well. So we want to talk about those differences that we see and what stands out to you from that graph. But what we want to see is, did the expected counts match the observed counts exactly? This is something we're going to be able to see after we run our test. But what we're going to try to prove is that we do see some differences right here. So I'm going to form a hypothesis for my test right here. My null hypothesis, since this is a test of homogeneity, we're going to be looking to, we're going to be talking about sameness here. So my null hypothesis would be that the adults have the same opinion as the faculty about the school. And you can probably word that better than me. I'm not an English person. But what we're going to be trying to prove is that, or what we're going to be trying to show evidence for, is that adults have different opinions than the faculty. Okay, so we want to assume that they're the same, but we're going to be trying to show that these differences that we see are statistically significant and they're just not random variation. If we did another sample, this may be different. Okay. Now, before we can show that evidence, we do have to check some conditions on the test. It does have to be random. This should have already been described in your introduction. It does have to have the large count condition checked, which means my expected counts have to be greater than or equal to 5. When you run your test, it's actually going to calculate these expected counts for you. So we'll verify these later. I'm going to go ahead and run the test, but I'm going to check later and just make sure that those expected counts are met. And my independence condition, my sample size, which if you add these all up and get a total, you can see what your sample size is. If you multiply that sample size by 10, that number should be less than your population. So let's just say I had a sample size of 500. If I multiply it by 10, it's 5,000. I would have to have more than 5,000 people in my population for this school in order for this to work. If your conditions are not met, then you probably want to adjust your sample size until it works. If it does work, if all of your conditions check out, then you're just going to make a statement in your report that you have met all of your conditions for this test and that you're going to proceed. So the next group is the steps on how to actually run this test in Minitab. Since you have already copied this into your report, this graph, I'm just going to X out of that. I don't need to save it. I already have it saved in my report. And I'm going to run through the steps for this test. So I'm going to go to Stat and go to Tables. And then step number 2 tells me to choose the chi-square test for association. Even though we're testing for homogeneity and not association, Minitab uses the same test for both of these. If when you're using your calculator, you just use a regular chi-square test for both of these. So even though it says association, we're still testing for homogeneity. In my pull down menu, step 3, we're going to choose summarized data in a two-way table. And then step 4, we're going to click in the columns containing the table box. We're going to highlight all of the columns over here on the left and click select. And then in the rows box, we're going to highlight C1 and hit select. I need to add that to the document here. And then you can hit OK. So what you can see is, let me go back to that test. I think I'm missing another thing right here too. Let me go to Stat, Tables. Yeah, I don't need to click OK right here yet. All right, so go back to the Stat, Tables and get that chi-square test for association back up. I also need to click Statistics and just make sure that it's going to show everything that I want it to show. You need to make sure chi-square test step 7 is checked, display count in each cell, display marginal counts, your expected cell counts, and you also want to check each cell's contribution to chi-square, because if we do see a difference in one of these groups, that contribution is going to show us where the biggest differences are occurring. So now you can click OK and OK. And your chart or your table is going to show you 3 different values in each category. So the first number, if you look down here at your key, the first number in each one of these groups is the actual count that we had in the table to begin with. The second row is that expected count that we had to check for our condition earlier, and all of those expected counts had to be greater than or equal to 5. If you scroll through the second number here, all of those do check out to be greater than or equal to 5, so we can verify that condition now. The third number in each of those sections is your contribution to chi-squared, which if I get statistical evidence of what this alternative hypothesis is, that's when I'm going to look at these. So also, if you scroll down, you're going to see where it's run the chi-square test, and it's giving you a p-value. Both of these p-values are 0. We're going to use the Pearson p-value of 0. And then underneath your steps for that, you've got the paragraph that shows you what we need to do with this. So remembering that my hypothesis was that I was assuming adults had the same opinion as the faculty, what I was trying to show evidence for is that they have different opinions than the faculty. So what we're going to do is use this p-value and link it to our alpha level. So I'm going to start with saying my p-value came out to be 0, and that value is less than 0.05. I'm using 0.05 because I was running a 95% confidence level test, which is pretty standard thing to start with. That 95% confidence level along with this 5% alpha level should always add up to 100%. We'll talk about in another video what happens if I change this to a different value. But because 0 is less than 0.05, you'll see here you're going to reject the null. And if I reject the null hypothesis, that means I have evidence of the alternative. And our alternative was that adults have different opinions. So I have evidence that adults have different opinions than the faculty. Okay. If this p-value had come out to be greater than 0.05, then we would have failed to reject the null hypothesis, and then I would not have evidence of the alternative. If we do not have evidence, we really don't have to go any further with this, but if we do have evidence that it's different, we want to talk about where we see those differences, which we had kind of already done looking at the graph. But it also, if you look at this table and your contributions to chi-squared, all of these were pretty much the same value. If you 30, 29, 31, 37, 10, here we had 61, 59, 63, 75, 21.2. If you look at the biggest contributions to chi-squared, this poor, we had a big difference in that. So there seems to be a big difference opinion in the poor category. Fair and good all seem to be pretty big. This one right here, this contribution 21, and if we compare that to your graph, which we had earlier, we see that in the poor category, the adults seem to be a little bit bigger, so that poor is a little bit different. The fair category is a little bit different. So just kind of look at where you see those differences and report out what you see from that. Okay, and that's where we were right there. So once you've run that test and you've gotten your conclusion, you do want to talk about what errors you could have made and what would have happened if you had changed your alpha level. So you want to, these will be separate videos. Make sure you watch those. Those will be the last two to add that final paragraph. You can use your calculator to run a chi-squared test of association. I'm going to go to stat. Stat edit. And if you have any old information in there, we're going to clear that out. So I'm going to go up to L1, hit clear, don't delete your column, and then come back down, and then go over to L2, hit clear, come back down, everything should be out, and we can enter our data into the calculator. So for L1, I'm going to do the first group of people that I talked to, which was the adults. So I'm going to enter the 321, the 900, the 750, 107, and 64. And then for L2, I'm going to type in the second group that I talked to that was the faculty, which is going to be my bottom row. Okay, and then I'll go to stat, right arrow over to test, and we're going to scroll down till we see the chi-square test. You don't want to do goodness of fit on this one, you just want the chi-square test letter C. Oh, my bad, I can't. We're not doing stat on this. I'm thinking of a goodness of fit. So just scratch what I just said on that. We have to use a matrix for this, I forgot. So just quit out everything, second quit. Your matrix is right here in blue above x to the -1. So I'm going to hit second matrix, and I want to right arrow over to edit, and we're going to choose number 1 for edit. You have a matrix in there already probably. We're just going to type over it to get the one that we want. And your matrix should be set up by the number of rows, by the number of columns. So we have 2 rows in this one. So I'll hit 2 enter. We have 1, 2, 3, 4, 5 different categories. So this should be a 2 by 5. If you get that backwards, it's going to give you a taller rectangle than a wider one. So you'll know to flip that around. And then we're just going to enter the values exactly as they look in your table. Okay. All right, from there, you're going to go to stat, right arrow over to test, go back to C and choose that chi-square test. Your observed counts are in matrix A, that's where we just stored them. Matrix B is automatically going to be computed with expected counts, so your calculator will do those for you as well. You don't have to type in anything for that, and then you can calculate. And what's going to give you is a p-value of 1.92, which it can't be that because probability can't be over 1. So I'm going to look back here. I'm going to see this e to the -89, which is scientific notation for times 10 to the -89th power. So we're going to be moving that decimal point to the left 89 times, which is going to make this really, really, really close to 0. That matches the same p-value that we got out of the Minitab. You use that p-value to make the same conclusions you made over here with Minitab. The only difference is that any graphs that you choose to use to display the differences would have to be done in some other program, or you'd have to draw this yourself. So your calculator will do that test for you. If you have any questions for me, make sure you email me or come by the office to speak to me. If you're in Danville, you can talk to your math teachers down there. Again, make sure that you watch the final 2 videos on types of errors and changes in alpha level. Good luck.